welcome to Unit Opener number 2. We're going to be solving a system of equations here by graphing, and you'll notice looking at it that one of the equations is linear but the other equation is not. So this will be a non-linear system of equations. We are going to start by graphing that top equation, which is a line, and again this looks like it's in slope-intercept form. The y-intercept is 2, and the slope, since this is just x by itself, that's really like it's 1x, so the slope is 1. So from here we would go up 1 over 1, up 1 over 1, up 1 over 1. And I'm not really sure how far I need to keep those points going, so I'm probably going to stop there. And it also goes in the other direction, down 1 to the left 1. Alright, well there's that line. Now the second one, of course, is not a line, and I guess you could graph this in a few different ways. I think what I'm going to do is just make a quick table, and I might include -2, -1, 0, 1, 2, 3. Okay, so if I substitute -2 into this equation, I get 3 to the -2 power, which can be rewritten as 1 over 3 to the +2 power, or 1/9. Alright, when I substitute -1 into the equation, I get 3 to the -1, which can be written as 1 over 3 to the +1, or 1/3. When I substitute 0, I get 3 to the 0 power, of course, is 1. When I substitute 1, 3 to the first is 3. When I substitute 2, 3 squared is 9. And when I substitute 3, 3 cubed is 27. Okay, next up, we are going to graph these points. So -2 is supposed to be at 1/9. Now, I don't know exactly where that is, but it's just a little bit above 0. -1 is 1/3. 0 is 1. 1 is 3. You'll notice that point overlaps. 2, 9, and of course 327 is way up here off the page. So this exponential graph looks like this. Sort of. And you have to remember that the exponential graph does keep going off to the left here. It actually has an asymptote at 0, because as we have these negative x values, it's getting closer and closer to 0, but it never actually gets to 0. So if you look at this graph, you can see that there are two places the graph intersects. One of them is there, and the other one is somewhere in this neighborhood. It's very close to -2. Although remember, the point on the line, the blue line, the point there is -2, 0, but the point on the red exponential graph is -2, 1/9. And 1/9 is close to 0, but it's not 0. So somewhere in that neighborhood they do intersect, although it's not exactly at -2. So only using a graph, you can see that it's really sort of impossible to get the solution to this system of equations. We know that one of the points is 1, 3. That satisfies both equations. And the other point is something that's at least in the neighborhood of 2 and in the neighborhood of 0 or 1/9. But it's just in the neighborhood. We don't actually have that point nailed down yet. So we'll have to use some other methods, which will be discussed in some later Unit 8 openers. It's also worth noting, actually, because this is a non-linear system of equations, these things happen to intersect in two different places. When you have two straight lines intersecting, at most they can intersect in one place, and in fact, sometimes they won't intersect at all. But if the two things are not linear, they can intersect many times, in this case 2 times. So when you're dealing with non-linear systems, you have to check and see how many solutions there really are.